we are going to do stationary points first. Okay, now for stationary points, there are three kinds. Oh, you listen up. Number one is a maximum point. Number two is a minimum point. Number three is called a point of inflection. Now, please know how to spell inflection. Not infection. Because some people write right? So exam right, point of inflection. No infection one in maths, you understand? You only find the virus and see the curve, that's all. No infection. And it's inflection, X-I-O-N, not T-I-O-N. You understand what I'm talking about? Point of inflection. Okay. Now, what do you mean by all this? Okay, I'm going to look up. Please stop talking. This one can score one. Confirm, double confirm. Now, if I have a curve and it goes like that, do you agree this is a maximum point? Correct or not? Maximum point means like that, right? Do you agree that if I draw a tangent, it will have gradient 0? Can? Minimum point, this one is a minimum point, right? If I draw a tangent at this particular point, the gradient will also be 0. Okay, now what do you mean by a point of inflection? Some curve very naughty, okay? They go like that. That somewhere down here when you draw the tangent, right, is 0, you know. Then you quickly turn away again. You understand what I'm talking about? So this is called a point of inflection. Okay? At stationary point, one thing holds. dy dx must be 0. Be it maximum, minimum, or point of inflection. dy dx must be 0. Everybody clear? Everybody clear? Okay, now, then you'll ask me, oh, Joe, like that how do I test whether is it a maximum, minimum, or is it a point of inflection? Then, of course, there are tests to deal with it. Now, there is one that is called the first derivative test. You test by differentiating once. There's another one that's called the second derivative test. Okay? Now, to me, right, both are okay. It doesn't matter. Okay, but sometimes second derivative will be inconclusive. That means you cannot say anything about it. Don't know what is it. Then you have to revert back to first derivative. I will teach you what is it. Don't worry. The textbook one example, I will give you one example. Understand? That one you must copy the notebook. Understand? Okay? Alright, now let's take a look at the first part here. Okay? Example 1. Can all of you look at example 1? The diagram shows part of the curve. Okay, let me just sketch this for you. Okay? This is P, this is Q. This equation is this. Okay? Now, I'm going to tell you this. Stationary point, maximum, minimum is very easy to score. You understand? In the exam. Okay? It's better than some other rubbish. I'm never bluff one, I confirm. I teach so many years, I know. Okay, students can score, so please score. Okay, now. The diagram shows part of the curve, blah blah, and two stationary points P and Q. Find dy dx. Of course, this one is revise, how to differentiate? How to differentiate? 6x squared, right? Minus 18x plus 12, right? This is the derivative, correct? Okay? Now, at stationary points, can you see this is a maximum, this is a minimum point? Okay? When dy dx is 0, what will happen? This is 0, right? Everybody clear? At stationary point, dy dx is always 0. Okay? Now, Can you see I can divide throughout by 6? So x squared minus 3x plus 2 equals to 0, right? Now, I use cross. I will have x minus 2, x minus 1 equals to 0, x equals to 2, or x equals to 1, right? Okay, what did the question say? Look at the question again. Find the coordinates of P and Q. Now, what do you think? Can you see P is nearer to the y-axis? This one must have x coordinate 1, right? Agree with me? How about this one? We'll have x coordinate what? 2, right? Agree, class? And how do I get the y coordinates? You sub in here. You sub in 1. How much do you get? You sub in 1. What do you get? Don't look at me. My face got no answer. You sub in 1, this is 2, right? 2 minus 9 plus 12 minus 5. What is it? Answer? 0, right? Don't do also know it's 0, why? It's on the y-axis, not. You see? Understand? Okay, so it's 0, right? But this one cannot say don't do, I also know. This one must do, okay? Plug in 2. All of you plug in 2. Okay? Negative 1. So it's correct. Can you see it's below the x-axis? So you get the negative 1. Everybody clear? Everybody clear with what I'm saying? Okay. Then I'm going to tell you how to do first derivative test. I always do faster than, I don't like the textbook way of dividing like that. I want you to have 2 in 1 straight away, you know. Everybody clear? Okay, now all of you look up, don't talk already, don't talk. Now, this is the first derivative, right? Okay? Now, for it to be a maximum point, it goes like that, correct? This is 0. Can you see this is positive gradient? This is what? Negative gradient, right? It must go like that. Then it becomes a maximum point, right? If it goes like that, that means negative, 0, positive, then it becomes a minimum point, right? Okay, class? Can? Okay. Now, all of you look here. Let's say they never give you the picture. Okay? Now, when x is 1, that means I'm looking at this point, right? What you do is that I always put x1, x slightly less than 1 will be 0.9, right? What is slightly more than 1? 1.1, right? Agree, class? Okay. You go and find the value of dy dx. You plug in 0.9, 0.9. All of you plug in now. This one. Tell me bigger or equal to 0. Plug in 0.9. Positive or negative? Okay? 0.36 feet. 0.6 what? Exact. 0.66 exact. Wow, so good. Okay. This one of course is 0 lah. If not 0 die already what? Just now we say 0 ma. Right? How about this one? Plug in 1.1. Plug in 1.1. All of you now. Negative 0. Exact. Okay, all of you look, all of you look. Can you see this is positive? Positive sum this way, 0, then negative, right? So, 1, 0 is a maximum point because it goes like that. You understand what I'm talking about? Okay, how about this other point? Of course, I know at this point is 0, right? What is slightly less than 2? 1.9, right? What is slightly more than 2? 2.1, right? Correct. All of you plug in now. To divide dy dx. I want to know this dy dx is what? Okay, you just need to tell me positive or negative can already. No need to give me the exact answer. Equals to what? Positive or negative? Plug in 1.9. Huh? Do you agree this is negative? How about this? It's positive, right? Negative means like that, right? Agree now? So, this guy is a minimum point. Everybody clear? This is called the first derivative test. Understand? First derivative test. Okay. Now, how would a point of inflection behave? Now, I told you right just now. Let's say this is 0. Can you see that a point of inflection, when you test, right? Maybe 3 or whatever, this dy dx is 0. This side will be positive, this side will also be positive because it goes like that. Or if this side is negative, this side is also negative. That is a point of inflection. It will not change. It goes like that. You see, either it goes like that or it goes like that. Understand? If the sign don't change for the first derivative, that means it's a point of inflection. Everybody clear with what I'm saying here? Yes or no? Yes. Okay. Then, next, how do I use the second derivative test? Now I'm going to write this here. 1, 0 is a maximum point. 2, negative 1 is a minimum point. Am I right? Everybody okay? Okay. Now, first, the second derivative is faster, but sometimes it's inconclusive, which is bad. Okay. Now, all of you look up here. Hello. I'm not following the textbook. Look at the textbook also no use. Okay. When you differentiate another time, it's called d2y dx squared. That means you differentiate this again. O will be O plus 12x minus what? 18, right? Okay? Second derivative very easy. When x is 1, you're right, I will get d2y dx squared equals to 12 minus 18, right? This is less than 0, can you see? When it's less than 0, that means it's talking about this side, less than 0. So it's the maximum point, straight away maximum. When d2y dx squared is negative, straight away maximum point. No need to go and here, there, everywhere. Understand what I'm talking about? Okay? How about when x is 2? What's d2y dx squared? 24 minus 18, right? What's 24 minus 18? Bigger than 0, right? So it will be a minimum point. Because bigger than 0. We look at the second part. Everybody clear? Okay? Now, I'm going to conclude here. First derivative test. All of you look up. Hello? Like that, 0, like that means maximum point. Like that means what? Minimum point, right? Negative, 0, positive, right? If second derivative test, second derivative test means you look at 2y dx squared. Okay? If it's negative, it's a maximum point. If it is positive, it is a minimum point. Okay? Can? Everybody clear? Okay, Alright, now can you all turn the textbook to page 50. Now, can you see they tell you minimum point, maximum point? Okay? Now, for point of inflection, hello? For point of inflection, The first derivative test will be like that, right? The sign don't change, or what? Like that. Is that clear? This is called point of inflection. Everybody clear? Can or not? The sign don't change. Okay. Now, how come we have to revert back to first derivative? Sometimes d2y dx squared is 0. When this is 0, you cannot straight away say it's point of inflection. It's not correct. Okay? What if you test d2y dx squared is 0? You must say inconclusive, go back to first derivative. Understand? It doesn't mean that d2y dx squared is 0 means point of inflection. That is nonsense. Everybody clear with what I'm talking about here? Okay? Alright, I want you to highlight something again for me. Can you turn to page 54? Can you see that if d2y dx squared is less than 0, is a maximum point, and d2y dx squared is more than 0, is a minimum point? Can you see what I'm talking about here? Yes or no? Yes, okay. Now, I want everybody to take down this example. Must take down. Okay, must. Okay. Can someone tell me what is dy dx? 30x 5, right? That's all right. Correct. For stationary points, dy dx must be what? 0. Okay, so when dy dx is 0, am I right? Yes or no? Okay, now when x is 0, what is my y? When x is 0, what's my y? 1. So actually the point is 0, 1, right? Okay? Correct or not, class? That means I have a stationary point at 0, 1. Agree? How do I know whether is it the maximum, minimum point, or point of inflection? Okay, let's say you're very happy, you want to do second derivative because very easy to differentiate, right? Okay. What is this if I differentiate again? 150 x4, right? Okay, this is the stationary point. When x is 0, what is d2y dx squared? 0. Can you say this is a point of inflection straight away? No, you cannot. Okay, so you cannot. You got to go back to what? First derivative, dy dx. Okay, so this one is inconclusive. Understand? Okay, then we have this. Slightly less than 0 will be what? Negative 0.1, right? Slightly more than 0 will be what? 0.1. Now, of course, this one I know dy dx is 0 lah. Right? Right? Now, when this is negative 0.1, can you see 30 plus times something negative and power 5? Sure negative, right? Do you agree this one will be negative? Agree or not? This is a positive number. So if I plug in here, it will be a positive number. Can you see? Yeah? So, dy dx will be positive, right? Negative 0 positive. What is this point? What is this point? This is actually a minimum point. Agree or not? Do you agree it's a minimum point? So does it mean that d2y dx squared 0 means point of inflection? No, it doesn't mean that at all. This is the misconception that students always have. Everybody clear? I tried very hard to find this question, right? So please copy down, understand? Don't don't appreciate also, at least take a look. Okay? Can or cannot? Okay? So, let me just say this. If d2y dx squared is 0, it's inconclusive, you've got to go back to first derivative. Everybody clear? So, actually my advice is, if dy dx is already very complicated, don't do d2y already, you die. You understand? Now, straight away plug in the first derivative. Clear? Okay? Alright, so are we okay so far? I just want you to have the basics first. Are you okay? Alright, okay, good. Then, I'm done with all this. I'm going to do example 2 now, which is on page 50. Okay, this is a good example because it shows you all three how to do it. Okay? Alright, all of you look up first. Hello? 2x cubed minus 6x squared minus 18x minus 5 has 2 stationary points. They tell you got 2 stationary points. Okay? Now, first of all, I'll find dy dx first. What is it? No class. 6x squared minus 12x minus 18, right? Everybody okay? Alright, Now, first part, show that dy dx is this. That means I got to factorize up 6 now, right? Then what do I get? Right? Now, if I use cross, I'll get x minus 3 x plus 1, right? Correct. So this is already shown. Everybody clear? Clear. Even if cannot show, also can use the thing. Okay? Now, find the coordinates of the stationary points. Okay, all look up. When dy dx is 0, I'll have this equals to 0, right? So can you see either x is 3 or x is negative 1? Everybody okay? Alright. When x is 3, what is my y? Plug in there. Plug in here. When x is 3, you will get a negative 59. Understand? Okay? How about when x is negative 1? Y will be what? Y will be 5. Everybody clear? So, this is the first stationary point. And then, this is the second stationary point. Okay? Everybody clear? Stationary point is always found when you equate dy dx to 0. I'm talking to 403. Yeah? Okay, good. Now, next part. By considering the sign of dy dx, determine the nature of these 2 points. Nature means they want to find whether it's a maximum, minimum, or point of inflection. But this particular question specifies for you. They want you to use what? Dy dx. They want you to use first derivative. Understand what I'm talking about? Okay, all look up. I always do this. Slightly less, slightly more, right? Okay. Okay, you tell me positive or negative. All of you plug in now. But I don't want you to look at the textbook, you plug in now. Now. Plug in here, 2.9. This one is what? Actually, by looking, you already know. 2.9 minus 3 is negative, right? negative and positive, this is negative. This is actually a negative value. Okay? How about this side? 3.1, positive, positive. So what? This is positive, am I right? So it's like this, like this, like this. So what kind of point? What kind of point? Minimum. Everybody okay? Yeah? How about the next point? You must know what is slightly more and slightly less. Some people when it comes to negative, you know already. Slightly, this is this side, right? Slightly less is negative 1.1, right? Slightly more is what? Negative 0.9, right? Okay, do this. What is the answer? This is a positive, am I right? How about here? It's a negative, correct? So it's like this, like this, like this, right? So what is this? Maximum point. So when they specify that you must use first derivative, this is the first derivative. Everybody clear with what I'm talking about here? Okay, now then my question is this. What if the question never specified? Can I leave this here? I do the second derivative on top. Okay, now. Okay, I leave like that so that you can compare. This is when they specify. If they don't specify, what is my d2y dx like? You don't go and do this, you do this one faster, understand? Okay, wow, die product rule, no need, just do from here. How to do? 12x minus 12, right? Okay. At 3, 12 into 3 minus 12, right? Can you see this is positive? Positive means what? Minimum point, can you see? Everybody okay? At 12 into negative 1 minus 12. This one is negative, so this will be a maximum point. Can you see? It will tally. So first or second derivative also never mind, unless the question specifies. Do you understand? Okay, then I want to ask, what if after you test, right, it's like that? Then what is this point? Point of inflection. Okay, likewise, if it is like that, it is also a point of inflection. Is that clear? Can or cannot? Can, huh? Okay, good. So that is our example 2. I hope you are fine. Now I'm going on to example 3, then I will stop for today. No homework. Will that be okay? But you must bear with me until example 3. They don't think that you're the only one that's tired. I'm also damn tired. You understand? Okay? Alright. Let's go example 3. Yeah? Okay, let's look at example 3. I promise you last example means last example. Okay? Given that y equals to x squared minus 1 cubed plus 3, find dy dx. Okay. I want to find dy dx. Very easy one, huh? Take down 3, right? X squared minus 1, 2, right? Times the inside is what? 2x, right? This one is 0, correct now? So final answer, 6x. Correct? Everybody okay? This is my dy dx, okay? How to get stationary point when dy dx is what? 0, okay? I will have, that means either x equals to 0 or x squared equals to 1, x is plus minus 1. A lot of you will miss that out. When you take square root, there must be plus minus 1. Correct now? So there are actually 3 stationary points. When x is 0, what is y? Don't look at me. Plug in. Hello. Plug, plug, plug. 全部跟我 plug. All plug. Answer? Answer? 2. So the first stationary point is 0, 2. When x is 1, what is y? What's y? 3. When x is negative 1, what is y? Answer? Also 3, right? Everybody clear? Everybody clear? Okay, now I'm not going to say this too much. All of you look up. When you go and test the 3, x equals to 0, x equals to negative 0 by 1, then x equals to 0 by 1, slightly more, slightly less. That kind of thing. Now, for the first point, okay, 0, 2, you will get like this. That means this is a minimum point. Agree? I'm just showing you the result. You must do the working. Okay, now the next one. Slightly less will be 0.9, right? Slightly more will be 1.1, right? Correct? So for 1, 3, you will get like this, like this, like this. So what is this? Point of inflection. Everybody okay? Now last point, negative 1. Slightly less is negative 1 by 1, right? Slightly more is what? Negative 0.9. You will get what is this? What is this? Again, a point of inflection. Everybody clear? Everybody clear with what I'm talking about? Okay, now I want to tell you something here. I told you last week. Okay? If you use second derivative, for these 2 points, right, you will get dy dx, d2y dx squared equals to 0. Then you have to go back to first derivative again. You understand? Because it's inconclusive. You get what I'm saying? Okay, let's try it out, right? All of you look up here. Hello? I say last means last, okay? Fix one, differentiate the other, right? So 2, 1, then times 2x, right? Okay? Plus, fix this one, differentiate the other, right? Which is 6. Okay? This will give me what? 24x squared, x squared minus 1, right? Plus what? 6 x squared minus 1 squared. Can you see what I'm talking about? Okay, now, if I use second derivative when x is 0, can you see this is 0? Can you see? This one is 0, right? When this is 0, this is 6. So this is a positive. Can you see it's positive? It is still a minimum point. Okay, how about when x is 1? You can see it's 0. This one also 0. You cannot conclude anything. How about when it's negative 1? All of you look up. When it's negative 1, you square is still 1, you know. So this is 0, this is still 0, you know. So you cannot conclude. Everybody clear? You must move back to the first derivative test. Everybody okay? Alright, good. I say I will stop at example 3. That means I will stop at example 3. Okay? Now, tomorrow, I'll be going on to example 4 and 5. Is that clear to 403? Okay? Alright, can we stop the video?